Look at this problem. Can you determine what must be placed on the blank to form a geometric sequence? You might use the formula in finding the nth term of geometric sequence to supply the middle term. Let's discover how to answer this problem. How can we solve this problem? The given terms are the first and last terms. These terms are called the extremes, and the term or terms in between the extremes are called geometric mean or geometric means. In the geometric sequence 3, 12, 48, 192, 768, 12 is a geometric mean between 3 and 48. 12 and 48 are geometric means between 3 and 192. 12, 48, and 192 are geometric means between 3 and 768, or 48 and 192 are geometric means of 12 and 768. Going back to our problem, how to solve the middle term or the geometric mean between 27 and 3. We cannot solve the middle term or the next number of 27 without finding or knowing the common ratio of the given geometric sequence. So how to solve R or the common ratio? To insert term or terms, let us identify first the common ratio by using the following formula. R is equal to n minus k root of a sub n over a sub k, where n is the number of terms, k is equal to 1 since it is the first term replacement, and r is the common ratio. So, the number of terms or n is equal to 3. Why? 2 given numbers plus 1 missing term, that's why the value of n is 3. K is equal to 1, which is constant. Take note, a sub 1 or the first term is equal to 27, and the third term or a sub 3 is equal to 3. In the formula, let's substitute the values of n and k. That becomes r is equal to 3 minus 1 root of a sub 3 over a sub 1. To continue, r is equal to 3 minus 1 is 2. That means that is square root of a sub 3 is 3. A sub 1 is 27. So therefore, that is square root of 3 over 27. And we will simplify what is inside the radical symbol, which is 3 over 27. Reduce that one to lowest term, that becomes 1 over 9 because the common factor is 3. Now, how to get the square root of a fraction or square root of 1 over 9? To get the square root, we will get the square root of the numerator and get also the square root of the denominator. So, square root of 1 is 1 and square root of 9 is 3. So, therefore, the square root of 1 over 9 is 1/3. And this is now our common ratio of the given geometric sequence, which is 1/3. Since we have obtained the value of r, we can now solve the missing term by multiplying 27 by its common ratio, which is 1/3. 27 is also equivalent to 27 over 1. So to multiply 27 and 1/3, we will multiply these two numerators and multiply also these two denominators. So 27 times 1 is equal to 27. 1 times 3, the product is 3. Then 27 divided by 3 is 9. So therefore, the missing term in the given geometric sequence is 9. Let's have another example. Insert geometric means of the following sequence: 3 halves, blank blank 81 over 16. So in this example, the value of n is 4 because we have two extremes and another two geometric means, which are the missing terms of the given sequence. And the value of k, of course, is 1, which is constant. Then copy the formula of computing the common ratio, which is r is equal to n minus k root of a sub n over a sub k. Then substitute the value of n and k. That becomes r is equal to 4 minus 1 root of a4 over a1. To continue, r is equal to 4 minus 1 is 3. So to read that one, that is cube root. So therefore, that is cube root of a sub 4 is 81 over 16 over a sub 1 is 3 halves. So therefore, that is cube root of 81 over 16 over 3 halves. So we will simplify first what is inside the radical symbol. That is finding the quotient of two fractions. So how to divide fractions? I will rewrite that one like this: 81 over 16 divided by 3 over 2. In the rule of dividing fractions, we will multiply the dividend by the reciprocal of its divisor. The first fraction is our dividend and the second fraction is our divisor. So, to get the quotient, we will copy the first fraction, 81 over 16. Then division will be changed into multiplication. But we will get the reciprocal of the divisor, which is 3 over 2. That becomes 2 over 3. We interchange only the numerator and the denominator. Before we will perform the multiplication process, we will do first the cancellation, which means we are going to cancel the common factor of the numerator and the denominator. 2 and 16, the common factor is 2. So therefore, we will divide 2 by 2, which is the common factor. That becomes 1. And 16 will be divided by the common factor, which is 2. That becomes 8. And 81 and 3, there is also a common factor, which is 3. So we will divide 81 by 3 and the quotient is 27. And we will divide 3, of course, by 3 and the answer is 1. Then we will multiply the remaining number on the numerator. 27 times 1, that is 27. Then 8 times 1, the product is 8. So, the quotient of 81 over 16 and 3 over 2 is 27 over 8. So, that becomes r is equal to the cube root of 27 over 8. How to get the cube root of the fraction? So, we will get the cube root of 27, that is 3. Why 3? Because when we multiply 3 by itself twice, the product is 27. 3 times 3 times 3 equals 27. So when we say cube root, that is 3 times. Then we will get also the cube root of 8, and the answer is 2. Because 2 times 2 times 2, the product is 8. So therefore, the cube root of 27 over 8 is 3 over 2. And therefore, this is now our common ratio, which is 3 over 2. And we will use this common ratio or the value of r to multiply the first term to get or obtain the second term, which is our missing term. So a sub 2, or the second term, that is 3 over 2 times 3 over 2. So 3 times 3 equals 9, 2 times 2 equals 4. So therefore, the second term is 9 over 4. And for a sub 3, or the third term, we will multiply the value of the second term, which is 9 over 4, by the common ratio, which is 3 over 2. So 9 times 3 equals 27. Then 4 times 2 equals 8. So therefore, this is now our third term. So the two geometric means of the given equation sequence are 9 over 4 and 27 over 8. To summarize in finding the geometric means of a given geometric sequence, first, compute the common ratio using the formula R is equal to n minus k root of a sub n over a sub 1. Second, multiply the first term by the computed value of R to obtain the next term. Then third, to find the other geometric means, follow the same process. Multiply the second term by its common ratio.